We'll start by defining a couple of terms that will help us when we're dealing with functions. And the first term is relation. And a relation is just any graph. Any two kinds of values that you can relate to one another and put on a rectangular coordinate system is a relation. A function is a special type of relation. And for any x, there's only one y value. And that's what's special about it. And the other thing is that it passes, because of this, it passes the vertical line test. And the vertical line test is a handy test where you take a vertical line and anywhere that you place it on your graph or your relation, it'll only intersect it 0 or 1 times. So any vertical line, only 0 or 1 times. If it passes the vertical line test, then it is a function. Otherwise, it's just a relation. Now, the domain is the values for x. So any of the values that you could have for x when you're actually graphing a relation or a function. And the range is the values for y. Okay. So if I look at this relation here, and I know it's a relation because it's graphed, but I want to know if it's a special type of relation, which is the function. To figure that out, I can use the vertical line test. So anywhere I put a vertical line, it'll eventually cross way up there. And here it crosses just 1 time. Anywhere I'm going to place a vertical line, it'll only cross my function, I know now, in 1 place. So this passes, and therefore it's a function. It says circle the function, so I'll circle that one. Now this one is a circle, and if I place a vertical line here, it's going to intersect with my circle 0 times, and that's okay because I can have it intersect 0 times and still be a function. If I put my vertical line right here, it's going to intersect 1 time, and that's okay. It could still be a function. But the problem is if I put my vertical line anywhere in here, it'll intersect my circle 2 times, and so it's going to fail my vertical line test, and the instructions here tell me to put an x through it because it's just a relation, not a special function. Now on C, this graph is a straight line, and anywhere that I put a vertical line, let's check, anywhere I put a vertical line, it's only going to intersect 1 time. And you can see 1 time there, 1 time, 1 time. For each line, only 1 intersection, so it passes. And therefore that is a function. Now this one, I could put my line over here, no intersections here, and suddenly I've got 2 intersections, so it is going to fail the vertical line test, and it's just a relation then. Now for each of them, I'd like to know what is the domain and what is the range. So the domain is the values for x, so I can look at going across in any of the values that I might have for x, like way out here at -infinity. If I went up high enough, would I eventually have a matching point on my graph if I use this, say -1000 for my x value? Would I eventually be able to go up and find a point that matches on for this parabola? And the answer is yes, so I know that I can go all the way out to -infinity, and then the same thing all the way out to +infinity for my x values. Eventually I'll be able to find a point on my graph if I go up high enough. So -infinity to +infinity for this function, and the range is going to be the y values. So if I'm down here at -1000, for example, and I come across, will I eventually hit a point on my graph? And the answer is no, because the first point that I would be able to have a y value that matches is right here, and if I go across, it's right there, 1, 2, 3, 4. So we'll say it's -4. And then as high as I can go in the y direction, if I have a y value of, say, +1,000, I would eventually be able to go right or left to a point on my graph. So I can say it does go all the way to +infinity. And then here at the -4, I have to decide, is this -4 included? And it sure looks like it's going right up to that number, so I'll put a square bracket to indicate my endpoint is included. Now, even though this failed the vertical line test, I can still come up with a domain and a range. And if I look in the x direction, I know that this is the farthest to the left that I'm going to be able to go. So 1, 2, 3, 4, 5. So it's -5. And in the x direction, right here is the farthest to the right. I'm going to be able to find a value on my circle. 1, 2, 3, 4, 5. It's also 5. And each of those points are included. So we'll put square brackets with them. And then to the south here in the y direction, 1, 2, 3, 4, 5, 6. So -6, and that's included all the way up to 1, 2, 3, 4, +4. And a square bracket again, because we'll assume that they're right on those points, so we're just kind of guessing on that right now. And remember, on the interval notation, we always put the smallest value to the left and the largest value to the right. And then one other thing is that -infinity always has a parenthesis, and +infinity always has a parenthesis too. And these would have a square bracket if the point is included, or a parenthesis if it's up to but not including the point. And we won't really see that until we get to inequalities. So we'll consider these points included. Now, for this next graph, I'm looking for values in the x direction, and I see no matter how far I go over to the left, there will eventually be a point that's included that's on my line. So for x's, I know I can go all the way to -infinity. And then as I go to the right, this will keep going up, but it is still going to keep going to the right, so I'll eventually be able to find a point in that direction too. So -infinity to +infinity. And it looks like it'll be the same thing for any y values. So the smallest y value I can think of, eventually I'll be able to move over and find a point on my line, and the largest y value, eventually I'll be able to move over. So it's also -infinity to +infinity. And for straight lines, you will typically have -infinity to +infinity for both the domain and the range. Now there is one exception, and that is going to be the straight vertical or straight horizontal lines. Here we have this crazy looking shape here, and this is kind of curving back this way, so we can assume it's continuing on like that, and this one is continuing off this way here. So we could look at these and say, for any x value I choose all the way to -infinity, I think this one's eventually going to get over that direction. And for +infinity for my x value, the same deal. So I'm going to call it -infinity to +infinity. And then for the y direction, down here at -infinity, since this is tipping down, it's eventually going to get wherever I head for my y direction. And all the way up through here, all the way, even my highest values in the positive y-axis will eventually have a point on this crazy looking line here. So very unusual looking graph, but -infinity to +infinity for the domain and range. Now for function notation, if we do have a function where we graphed up above, we use this notation f of x, and we say, as I just did, f of x, or a function of x, so either of those. And when we graph, we can really think of the f of x as being the same thing as a y. And so sometimes if you get stuck, just think of that whole notation as really just being a y, and it could help you out quite a bit. But we use the notation to tell us what we want to plug in for the x. So if I have f of x equals this nice quadratic, then I say I want to know what f of -2 is. And you can see that where I have